Hi everyone. So we have another MATHCOUNTS problem. So this was a number 30. So on the national test. So we have a solid right circular cone with radius 5 and height is 12 is given. And what is the probability that a randomly chosen point inside of this cone that is a distance of at least 1 centimeter away from the closest point on the surface of the cone? Okay, so it looks like a bit worthy, right? So we want to get at least 1 unit away from the closest point that is on the surface of the cone. Okay, so make sure you really understand what's being asked before you try anything. So, but this figure looks so like small. I'm gonna make it a bit bigger. So let's see if that might help. So what we are told, I don't need to take the entire figure. I'm gonna just take this much. So when you take a point, because that will be symmetric anyway, so any point you choose should be at least 1 unit, 1 centimeter away from the outside of that cone, like surface of the cone. So like, for example, if I choose, let's say 1 unit right here, right? So that's 1 unit, let's assume. So you can choose anything above. And then I can do all the way this way, right? So there is no concern on that line segments. I can do all the way here. But the problem is I cannot really choose this point because if this is like less than 1, so I need to make sure that's not just less than 1. So if this is the distance, right, that's a 1 unit because we need a perpendicular segments when we talk about the distance. So that needs to be 1 unit. And the same thing when you get to some point right here. So this doesn't have to be 1 unit because it cannot be, because if I find a point right here that's closer to the outside, so that's really perpendicular. So meaning that my point, the segment that is 1 unit distance has to be something like this. So meaning that the hypotenuse right here should be larger than 1 because this distance will be 1. Okay, so then what we are trying to find is the region this one. Let's see. This is the region that we are interested, because any point on this triangle or this 2D version is the good point. So we cannot choose anything that are outside of the triangle. But the question is, how do we find those, like the side so we can find the answer, right? So we know that this is 1 unit, okay, and we know this entire thing was 5. And then this is 12, and then this is 13, 5, 12, 13. And we know this is right angle. And then I do know the top angle. If I name this is A, and then this is B, C, let's say D, and then E. So the angle A and in this ABC and the angle A in ADE is congruent. So that's the shared angle. Angle 90 at C, angle 90 at this is also congruent. So that's also same, which means ABC and ADE are similar by angle. So the ratio, the angle A opposite to 1, angle A is opposite to 5, which means we have 1 to 5 ratio. So if that's the case, we can take the AE, which is 13 divided by 5. So that should be 13 over 5 for AB. And since this is 1, so I can find this distance as 12 minus 1 minus 13 over 5, which will be 11 minus 13 over 5. So 55 minus 13, which is 42 over 5. Okay, so this guy is 42 over 5. And similarly, like we can show that this triangle, the purple one, is similar to the larger one. And if you are not convinced, we can do, say, like this segment is parallel to AE, which will make this angle right here, and then this angle right here are congruent because they are corresponding. And this angle and E are also congruent because these segments are parallel. So meaning that this triangle and the larger one is also similar. And the ratio of the similarity, we can just find this segment divided by the corresponding side, which is this one, and we can find this one easily. So let's go ahead and do that. Like we can try that, I believe, easily. Or we can just say the ratio of the, okay, I think we can do that. Okay, let me try that ratio. So that's one side, right? And that's the opposite this angle in the purple triangle. So if I want to write 42 over 5 and divided by the same angle E in the larger triangle is opposite to 12, that's the ratio of the corresponding sides. And if I say this is X and then this is Y, so XY divide by 5. So that is my ratio. So the purple one and ADE are similar. So this is what we get if I write the ratio. Okay, so then if I do cross multiplication, the 5 and 5 will cancel. So you got 42 equals 12 times XY. So divide by 6. So the XY will be 7 over 2. So that is 7 over 2. Okay, now we want to find the probability, which is a region, which is like, but not a triangle. It is a 3D because we have a cone. So I just take the 2D version of that front like face looking. So that means we want to compare the volumes. So the volume of this region, which will be a cone. So if you do the extension on the other side, so you will have the smaller version of this cone with the height of 42 over 5 and the base is 7 over 2. So the volume ratio is going to be pi times like 1/3 times radius squared, which is 7 over 2 squared, times height, which is 42 over 5. And this is the volume of the new cone, that's the desired region. Divide this by 1/3 times pi times the radius squared times height. So as you say, these doesn't really matter. So we just need to divide these. But at the same time, this is a sprint test. We cannot use a calculator, but we are asked to write in the 1,000, which is not a fun stuff looking, but let's see if the numbers are good looking. So we have now like 49 over 4 times 42 over 5. But this is 25 times 12. I can like write as over 1 and multiply what by the numerator after swapping those numerator and denominator. So you got 25 times 12. I need to take numbers in a way that I can multiply easily. So I can multiply 4 by 25, which is 100. So I can multiply 5 by 2. So I need to remove the 6 from this guy. So that will make 7. So that will be 10 times 100, which is 1,000, which is the point. So 7 times 49 is going to be 343 divided by 1,000. So that is going to be 0.343. Okay, so it wasn't too bad, to be honest, especially for the last question on the national test. So that was just a similar triangles plus somehow really relating the volume, right? So I think that's it. Anyway, I'll see you in the next video.